about the queuing model, right, last week.
ครับ
So for this week, we start the new topic that is like, modeling again is about the simulation modeling. And I already post the case study. For the station model, it's going to be just one class. Okay, so today we finish this one. The content of the chapter is not much. Okay, so we spend not too much time for today about the contents, about the example. Okay, but before we start, just want to tell you about the schedule that I'm going to have guest speaker. Okay. The guest speaker is going to come on Thursday of the November 14th. November 14th, that we have class, right? So we have a guest speaker. November 14th, so please come, okay? Because I also come as well for November 14th. The guest speaker gonna give you the example of apply the analytics, right? Things, right? For the business problem, okay? So in this case, let's see. I'm going to show you. Okay. The topic is about innovative analytics, right? The business analytics in action. So we're gonna show you how apply the business analytics to the problem, the business problem, using the maybe case study, maybe mention about the inventory model, right? Inventory pooling model. So we study inventory already, right? So from the last two semesters, last semester, right? For inventory model, but the topic is using the business analytics, and also she gonna mention and talk about the inventory pooling model. You pull about the inventories in the retail business, and how can it tell the efficiency or the performance of the business, something like that. Okay. So one question for exam is going to come from guest speaker. Okay. Probably no calculation, maybe we're going to ask you about the knowledge or the concept or the main idea that you're getting from the class, something like that. Okay, so one question for sure from the guest speaker. So please come on November 14. So also come on November 14, okay, for the guest speaker. Yeah, I think that's it. Because we don't have any change about the schedule. Everything is going to be the same. Just November 14, we're going to have the guest speaker. Okay. Okay, let's talk about the topic for today, the solution modeling. As I mentioned that I will report the case study, so do this next week. Yeah. So we have a lot of case study, right? So not much for you, right? Okay. So at first, we will talk about the introduction, right? Including about the implementation of the simulation, what is this, about the simulations, and what is the benefit of simulation, those kind of things, right? And most of the main thing that we will focusing in this chapter is about Monte Carlo simulation. We will study the Monte Carlo simulation. So this is the simulation that using the concept of random sampling. Okay? Because Monte Carlo simulation we use a lot in the business problem. Okay, and after that we're gonna see several examples of the simulation. But anyway, for our class, the example that we're gonna discuss in our class, I'm gonna use the example from the attachment document, right, from the Microsoft Word file, right? That I'm not using the example in the slide, right? The reason is because some of them is just far from our business, just like maintenance or unloading. Maybe it's not that useful much for us. So we're gonna talk about the example in another cases normally was in the service industry, consumer behaviors, queuing. So that's why we're gonna do the example together based on the attached document. Right? So let's start. Okay. So what is simulation? So I believe that we all heard about this word before, and we know that the simulation, the keyword or the meaning of the simulation is that we are trying to, copying or duplicating the real system. So the main idea is that we are not doing anything with the real system. We just duplicate or the copy, right, the real system, right? So we developed the model that represented the real system, and we try to understand the behavior, and also sometimes we try to evaluate, right, the strategy with that system. Right? Simulation. So you might heard the word from the simulation game, or maybe the things about the pilot when they first trying to practice to be the pilot, the real one. They need to using the simulator machine, right, to simulate, right, the circumstance or the surroundings condition about control of the airplane, something like that. So this is the same thing, because the simulation is keyword is that we are not doing with the real system, right? We are trying to duplicate or copying and study the behavior of the real system from that model. And this is one of the most likely used in the quantitative tool for the simulation. This is because sometimes the problem that we try to solve or we try to study, sometimes we cannot express in the format of equation or using other form of computational method. So if we cannot write down the equation to explain and so on, so the best way to think about method to handle, maybe you can think about the simulation, because simulation is using the concept of trial and error, right? So we do several times, too many times to see about the trend, about the possibility that close to the answer, right? Because we try to too many times about it again and again for solve the problem. By the way, for the application of simulation that we can see a lot, especially in the business world, is that firstly we try to use the simulation to describe the behavior of the system, such as the consumer behavior. So you might think about, okay, what kind of behavior of the consumer or the customer that they arrive to your system, arrive to your shop, arrive to your restaurant. And so what do they do? For example, let's think about the queuing problem, right? So they're gonna buy the stuff more than 10 items or less than 10 items, or what kind of the method that they're gonna pay for their stuff, using the credit card or pay by cash or those kind of things. So we try to use the simulation to describe the behavior, right? So we see a lot in the consumer behavior problem, right? And secondly, besides the consumer behavior or study the behavior of the system, the simulation can be used as a tool to do like a prediction, right? The future prediction. This is because the simulation, we also have the multi-color simulation that using the random sampling that we need to have historical data. So then we can use the simulation to as a prediction method, right? To predict about what we want to predict in the future. Not mostly it's about the demand, something like that. And lastly, that we see a lot in business is that we can use the simulation to study the effect of the system that's going to change if you change some factor in the system. For example, let's say that we try to study what would be the queuing problem or the bottlenecks that's going to happen if we rearrange about the layout of the checking-in counter at the airport and also the security counter to change to the new one, right? So if you don't have any simulation tool, you may need to do like in the real system. So there's spend a lot of time and maybe it's impossible. but using the simulation, we do it in the computer. So if we change the layout of the security check counter, change the layout of the check-in counters, and see what would be the trend of the queuing that's gonna process right, in the system, of the process in the system from the customer or the passenger, and see which part of the system is going to be the bottlenecks that might be occur. So we can study it using the simulation, right? Let's see the computer. Because actually simulation we can apply in several fields. So not just the business, we also things in the case of manufacturing, in the case of using the logistics or the government or the military that they study about the weapons, or even though in the weather forecasting we can apply simulation as well. So I mentioned about the computer because the simulation we need to do actually in the real world, we need to using and develop the simulation in the computer, so we require the computers. So you might have like a software program, or you might have to write down about the algorithm by your own, or using the like Excel. So there are several ways to develop the simulation, right? But such as in the elective course of our MBA program, we also have the course of business simulation, right? Taught by Just Leon, Jan Yun. So you can, she's gonna continue, right? Talking about using the simulation, especially using the software program. It's called Arena program. So it's continue for my content that I described for today. Right? So if you interested, you might choose the Watson elective course. So in conclusion, so what kind of problem that we need or we can use the simulation to solve for? Firstly, for sure, the problem that's quite very complex and very large. So if you have the problem that very complex, so it's very difficult to explain using the equation. Sometimes you have the information that is uncertainty, so you might change a lot. So if you change some factor, you change some parameter a lot. So simulation is useful because you are not interfere with the real system, and also you can using the power of computer and the software to do again and again to study about the effect of the change in the system. And as I mentioned, right, if you have the problem that you cannot tell or describe using the equation or using other computational technique, I think about the simulation. And the last one is very important, is that if you don't want or if you don't need about the optimal solution, simulation is a good choice. Because simulation modeling will not provide you with the optimal solution. But the solution that's provided from the simulation modeling is just the solution that comes from, you try another again and again too many times and tell about the trend, tell about the answer that possible to be the optimal solution, but it's not the optimal solution, but it's very close to optimal solution. So if you are not need 100% optimal, right? So my think about the simulation is very useful. And this is the slide show you about the overall process of simulation. It's talk about the process that we need to start with define the problem. What is it? This is about we need to understand firstly that what kind of problem that you want to solve. So what is your objective? Right? You need to understand the problem, right? And also you need to understand what is the real system that you run right now to try to study or you try to duplicate to study. Right? And after you clearly define about your problem, clearly understand about the objective and the problem, then you need to specify the variables, just like the linear programming formulation, right? So you need to specify or determine the decision variable first, right, for your linear programming formulation. This is the same for the simulation. Once you have known about your problem, then the next step is that you need to specify the variable in your simulation system. But in the simulation, we have two types of decision variables, right? Two types of variables. The first variable we call controllable variables, and the second one we call uncontrollable variables, right? For controllable variable, it means that the variable that you know
or you have the right to, specify the value. So normally, controllable variable is just the policy or the fact or the thing that you specify the values, right, into the system. So we don't do anything much with that because we are the one that specify the value, right? But for uncontrollable variable, this is a variable that we have no idea, and we want to estimate this value of the value of this variable. So then uncontrollable variable is going to be the variable that we're going to use the power of simulation to generate and estimate the value. In the business problem, and I think more than 90% of our class, uncontrollable variable that very popular is for the demand. Right? Because we don't know about demand, but this is about the future thing. So we try to estimate the demand, something like that, using simulation, maybe lead time, maybe demand, maybe about the customer or the consumer decision. They're going to buy or not buy the product, something like that. So what would be their choice that they can make the decision? This is like the uncontrollable variables, right? So we're going to use the simulation to estimate that value. And then when you know that, okay, what are your controllable variable, what are your uncontrollable variable, then you try to construct the simulation model. Constructing the simulation model is mean that you try to, look at the real system and try to, duplicate, right, the process, or at least you know about the flow of the real system, what it's going to be. For example, if I said about the flow of the, customer who arrived at the Starbucks at the Junction Square, and then what happened next? They arrived at the coffee shop at the Starbucks, and then what next? They make an order, right? Make an order, and then they're gonna pay, and then waiting for the coffee, and then depart of the shop. Right? So this is like the flow. You need to understand. So that would be the way that you're going to construct the simulation model that duplicate the real one or the flow of the real system, right? And then you specify the value of controllable variable, right? Because you are the one that specify that value of that one. Controllable variable in this case, for example, you might think about the policy, or if we talk about the inventory, if you remember, we have like a reorder point, something like that. So maybe it's your policy that, okay, whenever your product or your staff in the warehouse is equal to 20 or below, that you need to make an order. So 20 is the one that you specify, right? That's like controllable variables, right? So this is the one that you may specify the value, and then you run conducting the simulation, run solution, and then you getting the result. And then before you apply or use it to implement, we do two things. We check about the result of the simulation. Firstly, we do like the verification thing, right? Verify what we try to study and try to see that, okay, about the model that we have developed, the calculation is correct or not, right? Or in the term of develop like the model with the computer, is there any bugs or is there any something that is might not correct about the programming, and also that's kind of verifying thing that we do. And the second thing is that we do like the validation. The validation or the validation means we try to validate the model that this is actually the one that represented the real system that we want to study. Okay, so we do two things, right? Verify the model and validate the model. And if everything is okay, so then we use the result to take an action or implement, right? So that would be the overall picture of the simulations. And next, let's talk about the time discrimination simulation. In our class, we're gonna divide the simulation model into three categories or three types. Monte Carlo simulation, operational gaming simulation, and the system simulation. Let's talk about the system simulation first. The system simulation is like the simulation that's suitable for the very big, very large, and very complex problem, such like the economic system, transportation system, or let's say we talk about the transportation system at the airport, something else. So it's very complex. So that would be the big one. So it's using like a big computer, supercomputer, and you need to do a lot of things with that simulation. So it's beyond our class for sure.
And for the original gaming, you can think about the simulation game. So when we talk about the case that in the system you have two or more players in the same system. So just like when you're playing the computer game that let's say that the game of playing, I didn't play football or ROE or I don't know. So you have a lot of players playing the same system, so it's quite complex a little bit. So this operational gaming. But another thing that we type of the simulation that we're going to talk today is about multi-color simulation. It's quite using the random sampling. We just use a lot in business because the multi-color simulation it can be used to estimate the demand, study about the giving problem, inventory analysis, and so on. So very useful. Right? So in conclusion, so what are the pros and cons of simulation model? Let's talk about the advantages of the simulation. So lastly, it's quite straightforward and very flexible. Why is flexible? Because you can change anything. Right? You can change everything because you are not interfering with the real system. You are doing in the computers. Right? So you can study everything. You can change everything. So you can answer what equation. If you have this factor, if you don't have that factor, what would be the system gonna react, or what would be the change in the system? You can know, right? Because you develop with the computers. And also using the power computer, you can save your time. Okay, maybe you are not waiting with the real system, because sometimes, let's say that if I using the simulation to study about the effects of this building, if we don't have that columns, what happened? In the real system, you are going to destroy that column and loading the load and see what effect, right? What the failure that we have. But in simulation, what happened? We just cut off that column in the computers, right? And loading, and it's going to calculate and show about the result. And also, based on the simulation, besides the time compression, we also have like the more interact with the system, because we can change, as I mentioned, that we can change everything, right? So if you want something that try to study, you can change immediately from the software, from the computers. And how about the disadvantages of the simulation? For sure that even though the simulation can help you to save your time because you are doing in the computer, but don't forget that the very complex and very large problem is not just only the real one that you spend a lot of time. When you try to develop the system in the simulation, it's gonna spend a lot of time as well. So sometimes the problem is very difficult, very complex. It might take long time as well, and sometimes you pay as an expense for collecting the data as well. And also, it's using the concept of trial and error, right? So the result from the simulation is not the optimal solution, so this is the disadvantage. And lastly, next thing is that the disadvantage is, don't forget that when you develop a model, it's come from your understanding of the modelers who develop the model, right? So if you misunderstand about the model, right, misunderstand about the real system, you are something wrong with them. They understand the wrong things, so you're going to develop the wrong model. And the last one is that the solution is very unique. Even though you do the same model, but you have the different condition, different time, maybe you need to have develop a little bit change of that model because it's not 100% similar. So you need to change something that belong to that condition. Okay. So that's all of the simulation as an introduction. So next, we're gonna come up to the Monte Carlo simulation. That will be the simulation that we're gonna study today, and I think it's just 20 minutes from now we finish for Monte Carlo simulation. Because the rest of the thing for the simulation is depend on your genius things. I cannot tell you what are the variables for this problem. Just like you formulate the linear programming, right? What are variables you need to know about your own. Just like the simulation, right?
Right? I can tell you about the process, right? But what is those things, the system you need to understand very well. But anyway, for our class, the simulation that we use is Monte Carlo, and we're going to use like the, develop like the hand simulation, not using the real computers, right? But for the case study, right, if you can using the computer, that's okay, right? So you can using the computer, that's okay, right? That's fine. Using the Excel, that's okay. But if you're using hand, it's enough. I think it's not that difficult. Okay, let's talk about Monte Carlo simulation. So, as I mentioned, the Monte Carlo simulation is about a simulation model that we're using the concept of random sampling. We're using the concept of random sampling. So, what is the random sampling mean? Firstly, it means that if you want to use the Monte Carlo simulation, you need to have historical data. You need to have historical data. You need to have the data. Or if you don't have historical data, you need to have like the, estimated probability from the expert or from yours, the expert, that what kind of percentage of that event is going to happen, right? Something like that. So because the random sampling things mean that we're going to use the random models, right, as a trigger, and we check with the random interval of the variable, and then it's going to generate the value. And the value that you estimate using the Monte Carlo simulation will not change from the past. For example, if you have the data, right, let's say 5 years from now, ago until now, and about the demand of your shop, let's say. And based on the 5-year historical data, your demand, daily demand, right, the demand for every day is range from 10 to 30 units. So it means that if you're using the Monte Carlo simulation to estimate the demand, let's say the future demand, the result cannot below 10 or more than 30. It needs to range between 10 to 30 because it's already happened just in the past. So we expect that in the future it's gonna happen again. So there is no way that in the future the demand is gonna more than 30 because in past 5 years that we have like the information, there is no demand equal to no demand more than 30, right? Or demand below 10, let's say. So the concept of Monte Carlo is that we have like a set of data or historical data or the percentage of the things that are going to happen in the future, and then we're going to generate a random number, and based on that data, you're going to construct like a range of, range of the value that's possible, right? And from the random number, you're going to recheck with the range, and then you can know what the answer. It's just like the experiments thing that we try to estimate the output from historical data, let's say. So we use a lot, especially for the, in the business of the, study of the consumer behaviors, right? I will show you. And this is like a, list of the problem that very useful when using the Monte Carlo simulation to solve for example, inventories, demand, queuing problems, or maintenance problem. So we can apply this Monte Carlo simulation. And this is like the 5 step of Monte Carlo simulation. So as I mentioned that I can tell about you just about the process, about the flow. But when you solve for the problem, it's that you need to understand what are the variables that involved with the system. But anyway, firstly, if you still remember, based on the flow chart that I just showed you, right, or the diagram that I just have shown you, we have uncontrollable variable, right? The one that we try to estimate. So if we find, okay, we know that what are the uncontrollable variables in our model, in our system, sorry. So then we're going to use the Monte Carlo simulation to estimate that value. So the first step that we're going to do is to setting up the probability distribution for that uncontrollable variables. Let's say demand. Now the problem is to try to estimate demand. Demand is your uncontrollable variable. So the first step you need to construct or setting up the probability distribution for the demand. And the second step is that based on the probability distribution from the first step, then you do like a cumulative probability distribution of that demand. And then for the third step is that based on the cumulative probability distribution, you have the right to develop the range of random number for that that variables, right? And then the fourth step is that we generate the random number. Okay, we have several ways to generate the random number, and then we do the simulation trial by using the random number to recheck with the random number interval from the first step, and then we can estimate the value. For example, based on the historical data, maybe right. Right now, let's say you try to estimate the behavior of the consumer that they're gonna buy or not buy your products. Right? So you collect the data in the past 10 months ago, and you believe that 60% of the customer gonna buy, 40% is not buy, right? From the past 10 months. So what does it mean? If we using the random number to use as a trigger to check with the rate that we're gonna do on this one, let's say that in our class random number that we're gonna use from 1 to 100, just 100 number. So based on 100 number, 60% is mean you're gonna have like a 60 number from 100, right? 40% is 40 number from 100. So if I'm saying that 60% the consumer or the customer gonna buy, 40% is not buy, they're not buy. So it means the number from 1 to 100. If I'm using 1 to 60 for range of the number that customers gonna buy, 61 to 100 they are not buy. Is the percent 40 and 60%, right? So then when you doing the multi-color solution, you're gonna generate the number. Maybe the way that you generate the number, maybe you can using like in the work time using the table, or maybe you can think about you have the basket, you have like the ball, write down the number from 1 to 100, right? And then let you to your random to select from the basket. Maybe you pick up, okay, you have the number 33. The 33, what happened? 33 is in the between the number from 1 to 60, right? So it's just that okay, people gonna buy, that customer gonna buy, because 33 is within the range of 1 to 60. 1 to 60 is represented for 60%, right? From 100 number. Okay, so this is just like the concept. I will show you, right? So I'm talking about random number. Once again, the number is the number that is random from the computer. It's not involved together. It's independent. They have several ways that we can develop the random number. You can using the computers, you can using the table, or you can think about in the casino that you have the rule that okay, you have that the metal ball that is random to stop at what the number of color, so you can use in that way. But if you're using the computers, let's think about the Excel. If you're using this command for in the Excel, you can have the random number, but that the number is not integer. It's generally like a lot of decimal point, and also they can have both negative and positive value. So you might need to specify some things in order to generate the number if you want that the number to be the integer value, right? Something like that. But this is not the one that we not doing in your class, because for us we're going to use this table to generate the number. In the exam, we're going to provide this table as well. And if you look at this table, how can we generate the number from this table? Firstly, this table shows about the number. All number in this table is random. It's not have any relationship. Right? And in our class, we use the random number just 2 digits. Right? Actually, 1 to 100. 1 we're using 01. 100 we're using the 10. Okay, just 100 number. And if you look at this table, you can see that it seems like that they already show you about the 2 digits for you, right? So the concept that we're gonna select the random number for the table is that firstly, you need to select it as a column or row only, vertical or horizontal only, right? We are not doing crosswords, right? So we just select column and row. That's it. And no matter what variable that you have in the system, but if you want to estimate and and using the random number as a trigger to estimate that value of the variable, you need to using the same criteria, right? The same criteria means, for example, let's say, suppose that I have two uncontrollable variables in the system. I want to generate the random number in order to use it in the Monte Carlo simulation to estimate the value of these two variables. I've decided that, okay, I'm going to use the column, but not the row. I can use vertical. So we have two variables, right? So the first variable, let's say that I'm going to generate 10 number of random number for the first variable. I might use 1, 2, 3. So I may use from the column number 1, 10 number. This is the random number for variable number 1. Okay, I use as the column. For the next variable, if you have the second one or the third one or the fourth one and so on, no matter what you have it, you need to select column only for that for the variable, right? As a random number. And the column that you can use for that variable, you can choose any column except the first one, because I choose the first one for the first variable only. And the same criteria is that you can see that I'm select the first column for the first variable, and I start with number 52. The 52 is the very first one, right, from the first row. So if you have another one, let's say the second variable, and you have to select the random number for that variable. Let's say that I'll choose maybe the fourth one, but you can see it's column as well. And the first number I have to select at the end, because it's the same label. I cannot select, okay, I cannot select something like this. Okay, use this one? No. Even though it's column as well, but it is not the same criteria. Because the first variable, you start with the first line, first row. So the rest of the variable that when you're gonna select the number, you need to apply the same rule. In this case, if you select something like this, it's not the same. Because it starts with from row number 5, this is row number 1. It's not the same. Okay. And the next the number for that variable, when you select the first one, then the second one just follow the number in the table as it be. For example, if you're using 52 and for that variable, the same variable, the second number you need to use 37, and then 82, 69, and so on. And let's say that you try to generate the number, let's say 30 number, and you select the column, and the one column you may have just 20, not have enough to 30. What we're gonna do? You're gonna use from this one to this one just 20, right? And then you connect with the second one. This 21, 22, 23, something, until you get 30 something. Okay? So, in conclusion, row or column only for all variables. Using the same criteria, means if you start with the first line, the next variable should be the first line. If you start with the first one, it should be like this. Let's say you start with this one. You select column, the first column, and you start with 82. Right? For the second variable, when you have to select the random number, you need to select any column, but start with the same level. So let's say this is 05, okay? And the next number, just let it be. For why we need to have the same criteria at first, because we need to make it all even, right? And after that, just let it be, because the number is random already. But if you select the one, start with the line number 3, let's say. The second one, you start with line number 5, you specify your own, right? You bias. It's not even. Because, okay, I want this one, so you bias. But if you have no choice, everything is even. And then let it be. After that, what number is going to be? Let it follow by the tables, and that will be the random. Okay? So do not skip. For example, if you start with 05, the next number is 71, and then 06 and 49. If you skip some number, and then, for example, 71, and then I don't like this number, and go for this one. No, this is bias. Because you are the one that's specific, right? You bias. We're doing just the first part. let this column row, and then so what will be the starting point, and then let it follow as it be. And this is the one I'm going to show you. Okay, we finished actually. Yeah, we finished Monte Carlo. We finished one. Okay, look at the example. You get an idea. I will provide additional information for this one. We have Harry. Harry is the owner of Harry Auto Tire. Harry is the owner of Harry Auto Tire. So Harry Auto Tire is the shop that selling about the radio tire of the car, right? So when you have a car and you want to change the tire, you change all 4 wheels, right? So we call one set, let's say. So now Harry, he wished to determine what the policy of the inventory of his radio tire. So then he have no idea about the demand. So he need the information about the demand in order to help develop the policy. So right now, Harry wish to estimate the demand, let's say from today to the next 10 days. Tomorrow demand, the next 2 day demand until the next 10 day demand. This is the demand that Harry want to estimate using the Monte Carlo simulation. So he collects the data on the past 200 days. So based on past 200 days, what happened? There's like 10 days that he cannot sell any car. But there's 0 set that he can sell. For past 200 days, they have like 20 days that he can he sold like 1 set, 40 days 2 set, 60 days 3 sets, 40 days 4 sets, and 30 days 5 sets. So what we have here is mean that if we're using the Monte Carlo simulation to estimate, it means that in the future, let's say tomorrow demand, there is no way that the demand that we're using the Monte Carlo simulation to estimate is going to more than 5. Because in the past 200 days, that we use as the base, that we use as the historical data for us, demand range from 0 to 5, right? So if we want to predict in the future, demand is going to any value based on 0 to 5, not 6, 7. Because there is no demand more than 5 in the past 200 days that we have. Okay? So this is what we're going to do. Firstly, in this system, we calculate the demand. And the demand is only one uncontrollable variable for us because we have no idea what will be the future value of the demand. So demand is the one that we want to estimate. So then we do the first step of Monte Carlo simulation, that we have to develop this probability distribution for the demand. So how can we do it? Okay, look at this. Based on past 100 days, demand equal to 0, we have 10 days, right? So the probability of demand 0 is just using 10 divided by 200, or we can call 5%. Based on 200 days, there's 5% that demand equal to 0, right? For demand equal to 1, we do the same way. We're using 20 divided by 200, we have 10%. So I would say there's 10% that demand equal to 1. Demand equal to 2 as well, we're using 40 divided by 200, but we have 20%. Demand equal to 3, 30%, 4, 20%, and 5, 15%. So this is first step. Right, so then we have the probability distribution. Just want to show the graph, nothing much. And then we develop the cumulative. What is the cumulative thing? So just look at the column number 4, the fourth one. So we just do the cumulative of the property that we have done in the previous slide. Start with 0.05, okay, 0.05, and then 0.05 plus 0.1, we have 0.15, right? 0.15 plus 0.2, we have 0.35, 0.35 plus 0.3, we have 0.65, 0.65 plus 0.2, we have 0.85, and 0.85 plus 0.15, we have 1. So this is like the cumulative of the distribution. You just cumulative the property that we have estimated from the previous step. We have this column. And based on this, what are the idea that we have here? Let's say, look at the demand equal to 0. Right now, based on the past historical data, 200 days, and the probability distribution that we calculate, we know that demand equal to 0 is 5%.
Don't forget that in the simulation, especially the multi-flow simulation using the concept of random sampling, we're gonna need the random number. And I told you already that the random number that we're gonna use, we use just only from the number from 1 to 100. Okay, 1 we're using O1, 2 we're using O2, 100 we're using the 0, right? So let's say we have 100 number, right? And based on 100 number, we know that in the past historical data, 5% demand equal to 0. So 5% from 1 to 100, just 5 number, right? So we start with O1, and just 5 number. O1, O2, O3, O4, 5. So this is 5 number, 5% from 100. So this is the range of random number from 1 to 100 that we can use it to represent it to be the range of demand equal to 0. Because if you, let's say you have the random number, right? Any number from 1 to 5, this is 5 number, right? It's gonna 5%. We can say, okay, if you have a number from O1 to O5, demand equal to 0, right? And you can see the upper bound here, O5 is come from what? Come from the cumulative Pauli distribution. So for the next level, if this one, the previous one stop at O5 number, the next level we run continue, start with O6. O6 to what? To 0.15, right? So 15. O6 to 15, 10 number. O6, O7, O8, O9, 10, 11, 12, 13, 14, 15, we have 10 number. 10 number is 10%. That demand equal to 1, right? We do the same way. If one stop at 15, the next level start with 16, run continue. 16 to what? To 35. The next level is done from 36 to what? To 65. 66 to 85. 86 to 100, that was 0. So what is mean here? The last column here we have like the range of random number interval that we use is represented for each demand. So it means that if we have random number, let's say I let you to random the number from the basket, and you pick up is let's say 40. 40 is in the range of 36 to 65, right? So it means demand equal to 3. Right? Because the chance of each demand that's going to happen is based on the percentage of the number that belong to that range, right? So because let's say demand equal to 3, you estimate from the past 100 days 30%. We have 30 number in 100. If you have any number from 36 to 65, you can say this is demand equal to 3, right? 30 number for 100 is 30%. So in this case, let's say that I select the number, let's say we need to estimate 10 days, right, of the demand. So 10 days of demand, so I'm using the first column. And this is, I start with 52, so it's the 10 random number of mine. So I start with 52, what happened? 52 is used for the random number of tomorrow demand. 52, and then I will check with the rate. 52 is the rate of 30 to 65. Okay, I said tomorrow demand is 3. The next number is 37, it's demand for the next 2 days. 37, again, I will check with the rate. 37 is in this rate, right? Demand also equal to 3. The next number is 82. 82, you check in the rate, 82 in this rate, 66 to 85. Demand equal to 4. Something like that. So we have 10 random numbers, so you have 10 demand. So this is the concept of multi-color simulation, random sampling. You random the number, right? You random this number, and then you will check with the range. The range is developed from the historical data, right? So the chance that which number that you're going to be for the demand is depend on the how many percent of the past 200 days, right, of that demand. So in this case, what happened? If you select the set of random number that different from me, right, that maybe you're using another set, you have different answer. That's for sure, right? No one wrong. What depends on you? Which set of random number that you can select? Because this is just a small problem. So if I said based on my answer, this is demand for 10 days. I try to calculate the average value. I have 3.9. Okay, we have 3.9. This is the average daily demand, the offline, right? That we select that circle the number, 10 number from the first column. But if you have this information, actually, you can see that you know about the value. Each value you know about the probability to happen. So actually, from this, based on your knowledge of your stat, right? Such as cost. So you can find something we call expected value. So expected value for the demand, in this case, we're using 0.05 or 5%, multiplied with 0, plus 0.1 or 10%, multiplied with 1, plus 0.2 or 20%, multiplied with 2, right? Until you pass the last one, 0.15 multiplied with 5. Then you're going to have the expected value of demand. In this case, what happened here, you're going to have like the 2.95. And you can see it's quite different a lot. Concept of stat, that expected value should be have the 2.95 for the average one. But we're using the Monte Carlo simulation for just one set of the number. We have the average one is 3.9. But don't forget, this is just the small one. If you have more than 10, you're using 100 value, and you run this something like this, let's say 10,000 times, and you try to find the average of all that overall, you can find that the number is gonna close to 2.95. So, I mean, for the real Monte Carlo simulation, right? We're gonna do something like, just like the stat card. For example, with your 95% or 99% of confidence, you believe that the demand is going to range from this one to that one, something like that. We cannot specify, okay, demand equal to 2.9. We can say that, okay, based on your confidence 99% or 95%, you believe that demand is going to lie within the range of 2.9 to 2.8, something like that. So this is the real Monte Carlo. We're going to do the static. But for our class, we will not go through that way. We stop just, the way that you using the random number to recheck with the rate of the number, and you can estimate the value, and that's it. So we stop just the previous slide. We are not doing the static, okay? Because if you want to do the real simulation, you need to run a lot of, too many times, using too many samples, and then you develop like, your interval, right? The upper limit and lower limit, something like that, and using the concept of stat, right, to tell that with your interval of your confidence, so what kind of demand is going to be. But for our class, we stop just, okay, that you generate the number, and then you recheck with the rate of the number, and you can know about the answer, and that's it. Okay? So, because we're using this one a lot for the consumer behavior problem, the problem of queuing and the problem of the service business. So we are not doing go more than this. Okay. So actually, we finished with the Monte Carlo simulation, just the concept. Okay. So when you see the example, you're gonna very clear what we're gonna do. But as I mentioned, there is something that you need to, using your genius thing to estimate, to know what you're gonna do, because just like the flow of the business flow of the system. So let's go to, the first example. Let me check.
On top
Okay,
opportunity.
let's take this example. Okay, we have like a company is called Flyme Companies. It's a travel agency. They do for both domestic and international. Currently, the company has two new travel packages to the new country. The first package is to visit Africa. The price is 80,000 baht. And the second package is visit the South America, where the price is 60,000 baht. So as a result, the company plan to do the market by promoting these two packages to the existing group of customers who are the business executives. So the sales team prepare the package to offer the customer, and after the meeting as well as describe and offer the tour package to the customer, the company expects to have 60% of customers who will buy the package. And the probability that the customer will choose one of the tour packages as shown as follows. So we have Africa and South America, and this is the probability of customer to select the package, 60% and 40%. And also based on the data from the customer in the past, the company found that 55% of the customer who buy the package will pay with the credit card, and the remaining 45% will pay with the money transfer. So using the multi-color solution to simulate the sale of such a package tour with 10 customers, and then answer the following question. Okay, so in this case, you can see that we have the problem of customer behavior. One thing that we need to do is, okay, what kind of variable that we have no idea and we don't know in the system. So for sure, first thing is about the customer decision, right? That they're gonna buy or not to buy the package tour. And the second one is, if they buy, which package tour that they're gonna select, right? And the third one is that about the payment method, right? Because the payment is quite different, right? Because we have like the credit card and money transfer. Right? So in this case, we need to, estimate the variable, and we have 3 variables. So in this case, we can do like this. Okay. Let me just a little bit information. Okay. Okay, firstly, right, we need to develop the distribution for the variable that we want to estimate the value. In this case, we have right the customer decision. Let's see. We have buy, not buy. What do we have here? We estimate. We know our probability by 60%, not by 40%. Right? So it's different from the example, the first one that we see in the PowerPoint slide, because based on that example, the information that we have like a frequency. So we need to estimate the probability from that frequency. But in this case, we already have the probability that we estimate, right? So in the real world, so it's subjective. So if you're not using the historical data, so you need to using your experience, your vision, and you think so what kind of percentage for each of the options that's going to be your probability. So once you have the probability, so then you develop the cumulative, right? Probability distribution. So this case is going to be 0.6, and 0.6 plus 0.4 we have 1. So if I am using Rn1, if I'm using Rn1 to be the random number interval for the customer decision, so it means that if you have the number from 01 to 60, we can imply that the customer is going to buy the package. 61 to 100 or 00, they will not buy. So the next variable that we need to estimate is about the package tour, right? So for the package tour, we have Africa, let's say, and South America. Let's say. So we also have the probability for that. This is price tick as well. This is price flow as well. So again, the same probability distribution. We have price tick, we have 1. So if we're using Rn2 to be the random number interval for the package tour, if you have the number 01 to 60, Africa, 61 to 100 or 00 is South America. The third one is about the payment method. For the payment method, once again, we have credit card and money transfer. So we have the probability. This one is 55%, this one is 45%. So the cumulative probability distribution be 55, this one 21, and we're using Rn3 to be the random number interval for the payment method. This means that 01 to 55 is credit card, 56 to 100 is money transfer. So then we have finished construct about the random number interval for all uncontrollable variables of this system. So the next one is that we need to simulate. So then you need to generate a random number. I will use the table, and let's say that so we can use the table. Okay, and suppose that I'm going to use the information from the first row. Let's say this one. This. So let's say I'm going to use this first row. 10 number, start with 52. I select this one, okay, to simulate. So then we're gonna have like a, okay, starting with customer number 1. Then we generate the first random number for customer decision. So the first random number is 52. 52 is the range of 01 to 60, right? So then the decision is what?
Buy.
Buy. I'm using this one. Okay, buy. So the first customer, they can buy. And then what next? Which packet? Rn2. So the second number that I'm going to use, okay, show you here. This is the first one, addition. The second one, I'm going to use this. And the third one, I'm going to use this. Okay? The first row for the first variable, customer decision. The second row for the packet tour. And the third row for payment method. So then in this case, the Rn2 start with 37. 37 is in the range of 01 to 60. Is Africa. So the packet tour that they select is Africa. What next? We generate the third random number, start with 82. 82 in the range of 56 to 100. So the payment that we're going to have is about the money transfer. money transfer. So they have the revenue, Africa, right? 80,000 baht. How about the second customer? The next one is O6, like the first row. O6 is what? O6 is the range of 01 to 60, so still buy. The next one is 63. 63 is the range of 61 to the 10 or 100, so the packet will be by South America. The next number for payment is 57. 57 in the range of 56 to 100. Once again, we transfer. So we have another 60,000 as a revenue. The third customer from O6 we have 50. 50 still in the range of 01 to 60. So customers still buy. Which packet? The next is 28. 28 is the range of 01 to 60, still Africa. What the payment of next for 57 is 68. 68 is still the transfer method. So you have another 80,000 baht. Customer number 4, let's say. The next random number for the first one is 88. And you can see that 88 is in the range of 61 to 100, right? Customer will not buy. If this customer not buy, you don't have to do the next simulate. What next? Customer number 5. From 88 you have 53. 53 still buy. And you can see from RN2, in this case, the next number that you can use should be O2. Okay, O2. Not using 74. Okay. Why is O2? Because you stop at 28, right? The next number you need to run the number just continue from the previous one should be O2. If you select 74, because you're using the concept that okay, the first one you use 53, so the second number set should be the one that like the same level is not true. Because you bias, you just follow the next number from that set. We finish for the second set, write the number for the packet tour. Actually, we finish with 28, right? And then we stop because customer number 4 they are not buy. This customer not buy. For customer number 5, the next number from I2 you need to use O2 because O2 is connected from 28 in the table. Okay, just continue. Okay, so in this case is O2. O2 is still Africa. Same for the third set. 68, the next number you need to use in 28. 28 and now using credit card, and then you have another 80,000. So customer number 6, the next is 30. So customer buy. Another one is 74, is South America. And then 05, still credit card, we have another 60,000 baht. Customer number 7, 10. 10 still buy, right? Then have 35 is Africa. And then we have 94 is transfer. And you have the 80,000. Customer number 8, we have 47, still buy. Right. 24, Africa. 03, you pay by card, you have another 80,000 baht. Customer number 9 is 99, right? 99 is not buy. So we don't have to separate here. Number 10 is 37 is buy. So the next number you need to use the number that's right next to 24 is 03. 03 is Africa, and this one is 11. You pay by card, you have another $80,000. So we just developed the 10th customer by using the Monte Carlo simulation to simulate the behavior of this customer. Start with the decision that you're gonna buy or not buy, the package tour if they buy, and the payment method, right? So just like this, so not that difficult, right? Because this is just things that, but we still need to answer the question. The question is that we have the first one that how many customers interested in buying the package tour to visit Africa? Have 1, 2, 3, 4, 5, 6 customers. The second one, how much the company earn from selling one package? So you just sum up the revenue, right? 1, 2, 3, 4, 5, 6. 600,000. 600,000. And how about number 3? How much the company earn from selling the own package tour? So we don't have it actually unmodified from the previous one. Actually, we have the old and new package. So I'm sorry about this. I forgot to check the question. Just keep the question 3, okay? And question 4, how much the company is getting payment by money transfer? So we have 1, 2, 3, 4. You have 30, 300. You have 300. So 300,000, right? Money transfer, we have 4 persons. Yeah, 300,000. 300,000. So this is the first example, right? So just not that difficult, I think. So what would be the difficult thing of the solution? Actually, the difficult thing is this. You need to know about the flow of the system. From this, and what next? It is just normal. So sometimes flow is not just the same. For example, let's say that you're gonna do like the system that let the customer to buy a car. So someone may think about the brand first. Another one might not think the brand first. They think about the type of the car, SUV or sedan first, something like that. Right? So it's okay. But in this case, so if you start with the payment, it's not that true. So you should start with the customer caravan, not brand first. Okay, so we have the 3 or 4 next examples, so you get used to it, right? So let's see. So this first example, okay, the content we finished, we have about 3 or 4 examples. So let's have a break, okay? And then when you come back from the break, so we're gonna do the rest of the example. Okay?